Hi math lovers, welcome to notes number 23. We're on lesson 1.4 today. We're going to work with quadratic equations. All right, so I want to talk about ways we can solve quadratic equations. The first way we can solve it is by using the zero product property. You know and love this one. Anytime you can factor, it's the fastest way. You take all your factors, you set them equal to zero. The second way is completing the square. I'm going to hold off and I'm going to do this one tomorrow, all right? So this one's going to come tomorrow. And then I've got the quadratic formula. I'm pretty sure you remember this from Algebra 1. The quadratic formula, maybe you used to sing it as a song, like Pop Goes the Weasel. If you're really interested, you could Google quadratic formula song and you'll have lots and lots of people all over the internet singing the quadratic formula. Maybe you even want to make your own and share it with the class. Oh, that would be so much fun. So what the quadratic formula says is if it's of the form ax squared plus bx plus c equals 0, and a is not equal to 0, it's important that we say that because then it would not be a quadratic if a were 0, all right? Then we have the formula negative b plus or minus the square root of b squared minus 4ac all over 2a. The part underneath the radical sign, this part right here, is called the discriminant. And if I know underneath the radical sign, if the discriminant is positive, I'm going to have two unequal real roots. It makes sense that if underneath the radical sign is positive, I'm going to have two roots because it's plus or minus. If under here is negative, I'm going to have two roots and they're going to be imaginary. Okay, square root of a negative number is imaginary. And if it's equal to 0, well, the square root of 0 is 0, plus 0 and minus 0, then I'm only going to have one real root. So that's going to be helpful. All right, so there are some homework problems tonight, just in the problem set that talk about the discriminant. Don't be uncomfortable with those. All right, so let's jump right in. Let's try some problems. I have a couple for us today. I'm looking at number 1. I'm staring at it, and I don't know about you, but it's just talking to me. I see that 14, and I'm thinking 7 and 2. And if I can go ahead and factor this to x minus 7 and x plus 2 equals 0, isn't that just the easiest way to go ahead and solve it? Go ahead, set each of these factors equal to 0. X minus 7 equals 0, or x plus 2 equals 0. So x is equal to 7, or x is equal to negative 2. Okay, so I have two solutions. Or, remember it's an or in between, not an and. Okay, so I have two possible solutions there, right? Easy peasy. But number 2, I'm staring at it and it's not talking to me, all right? So what I'm going to need to do is I'm going to use the discriminant. I'm going to use the quadratic formula. Let's look at the coefficients. I have a is equal to 5, b is equal to 4, and c is equal to negative 2. I always find kids do much better if they go ahead and they say what a, b, and c are before they jump in and put the formula in. All right, so x is equal to the opposite of b, so negative 4, plus or minus the square root of b squared, so 4 squared, minus 4 times a in this case is 5, times c, which is negative 2, all over 2a, so 2 times 5. Oh, all I have to do is clean this up. X is equal to negative 4 plus or minus the square root of 16. 5 times 4 is 20, times 2 is 40, negative times a negative is positive, so positive 40 here, all over 2a, which is 10. So x is equal to negative 4, going off the page here, plus or minus the square root of 56 over 10. And so let's say x is equal to negative 4 plus or minus 56. I'm thinking about 56. I know that that's 4 times 14, and 4 is a perfect square. So 2 root 14 over 10. Now, when I used to teach Algebra 1, I used to make the kids write it as two fractions like this. So they were sure to reduce each term by the 10 in the denominator. If you're someone that makes mistakes like that, it's a nice little trick. 2 goes into 10 5 times. I highly doubt you'll be making those mistakes. You wouldn't be in my honors class if you didn't know how to reduce a fraction. Okay. And then I've got number 3. Oops, I'm off the page. There it is, number 3. Let's talk about this one. This does not look like that form, does it? No. Before I do anything, I'm trying to mess with you, right? So let's get, this is your diva. We always keep our diva positive. It's the diva of the problem. 4x squared. Let's bring the other terms over to her. Okay, we keep the diva positive. A is equal to 4, B is equal to -5, C is equal to 3. We're going to do the exact same thing, kids. We're going to plug it right back into our quadratic formula. X is equal to, let's see, opposite of -5, plus or minus the square root of B squared. So -5 squared minus 4 times A, which is 4, times C, which is 3, all over 2A, so 2 times 4. All right, let's clean this up. Opposite of a negative is a positive. So I have 5 plus or minus the square root of 25 minus 4 times 4 is 16, times 3 gives me 48. All right, so I'm starting to sense I'm going to have a negative underneath my square root. Now, in our textbook, we have not covered imaginary numbers, but they're coming. They're coming in notes number 26. So in just like 3 days, we'll be doing imaginary. So let's go ahead. Let's forge ahead. I know you honors kids have a thirst for knowledge, right? I've got to quench that. All right. So if you want to stop here and just say absolutely no reals, no real solution, that's fine today. Okay. In 3 days, that won't be fine. But anyway. We could say x is equal to 5 plus or minus, take out the imaginary number, so it'd be I root 23 over 8. Okay, so for this problem set, you could say no real solution. All right, if your domain is all reals, now notice up here, I didn't say what the domain was. Okay, I didn't give a domain. But down here, I have an imaginary. Okay, have fun with your problem set. Watch out for those imaginary numbers.